Hello everybody. Today we start with a new chapter in ICSE Standard 10th Chemistry, the most important chapter of chemistry, and that is organic chemistry. In fact, you have got just a chapter, but I would say that organic chemistry is a subject by itself. It's a huge topic with lots of things to understand. Something which you have not seen up till now, so it is not going to be so easy to understand also. So we will be very careful, very attentive when we are going through this video. Organic chemistry is basically chemistry related to carbon compounds which are formed by covalency. So carbon, when it forms compounds with hydrogen, mainly hydrogen, and with covalency over there, and also due to the property of carbon to form into chains, the long chain. So that is the main kind of issue about the organic chemistry. The organic chemistry is mainly the study of carbon compounds. Now, to start with, we'll just start with the introduction, what is there in the textbook. So we are referring to Viraf Dalal textbook, and we are on page number 220. So let's start with the chapter Organic Chemistry. First of all is terms, sources and importance of organic chemistry or compound. Lavoisier in 1785 classified substances into organic, that is vegetable, animal origin, and inorganic. So the first thing what came up was that certain kind of substances which were found only through animals, that is organisms. So Lavoisier identified those substances as something which are naturally available and cannot be in a form of a chemistry, and hence he named it as organic chemistry. And another one which was not made by the animals or basically any particular living organism is called as inorganic chemistry. So hence the first differentiation between the two was that organic chemistry was the one which was formed by organs, okay, the organs or organism. So when the organism is producing those kind of substances, those substances are going to be the organic material or organic compounds, and those which are not produced by the organisms or they are called as inorganic substances. Berzelius in 1800 stated that a vital force was necessary for producing organic compounds. So Berzelius found that these are certain things which cannot be like, they are not like combinations of acha ye add kiya and you are forming it a compound. They are something like some vital force is required in the nature which is producing these ones. So that's why they were considering that organic substances are just something which is not connected to chemistry at all, and that's why it was a separate branch altogether. Wohler in 1828 first proved the natural vital force theory wrong by synthesizing urea. So up till that time, all the compounds which were present as organic substances like the tartric acid or acetic acid or citric acid or methane or propane or petroleum. So all these were considered, or kerosene, at that time whatever was the hydrocarbon used, they were all considered to be as a natural product which is formed by some kind of a vital force. Now it was Wohler in 1828 that he discovered that it can be possible to even generate the compounds which are organic in nature by means of chemical means, and hence it was first it break that myth that the organic compounds required some vital force for its compound formation. So that's why he made urea as the first organic substance which was converted as a chemical substance. So hence we see the organic chemistry, it is a chemistry of specific carbon compounds except for oxides, that is carbonates, carbides, but most carbon compounds grouped into organic chemistry. So that's why we consider organic chemistry as the chemistry of carbon compounds, but except for the carbon, the oxides of the carbon or carbonates of the and bicarbonates of the carbon, or most of the other carbon at the other elements of carbon or other compounds of carbon will be under the category of organic chemistry. Next is hydrocarbons. Organic compounds composed of carbon and hydrogen only, that is methane, ethene, ethine. So these are examples of hydrocarbons. That means the compound which are formed only by carbon and hydrogen. So number of carbon atoms and number of hydrogen atoms combined together to give a particular compound that were called as hydrocarbons. Natural sources of organic compounds are, of course, we know that the natural sources, initially also we knew that the organic compounds were the compounds which were formed by nature. So the natural sources of the organic compounds are basically plants, which produces carbohydrates. The carbohydrates, the starch, the glucose, what we eat, they all are the kind of organic compounds. So we have carbohydrates, acids, animal proteins and urea, and coal, dyes and drugs. All these are examples of natural sources of organic material. So organic material can be available naturally by nature, that is because many of the organisms, that is the plants as well as animals, are going to produce this in a large quantity. And also the dyes and drugs, there are many like petroleum products and all are also found in nature, which are going to be nothing but organic compounds. And finally, the importance of organic compounds. Compounds are organic in nature are food, that is those you can see organic compounds are there in all the fields. So each and every field, if you see, there is some of the organic compound which we are using on our day-to-day basis. Okay, means it's in a daily routine we are using those things. For example, food, the carbohydrates. The carbohydrates would be the starch, the glucose, all what we eat. They are the carbohydrates. What we eat are nothing but organic compounds. The dyes, that is azo dyes, or clothing, that is cotton, nylon, and then the all polyester. All these are organic compounds. So the clothing is it is used for clothing. Fuel, petrol, petrol, diesel, all of them are organic compounds. And finally, medicines like penicillin, are again are organic compounds. So you can see the it is widely, the importance of organic compound is in a wide use. You can see even the plastic what we use is an organic compound. So the pen which you are using, the everything, the phone cover, everything is basically organic compound. So that's why organic compound has a vast utility. In fact, there are millions and millions of already existing organic compounds, and daily there are new inventions coming up to make more and more different kinds of organic compounds. So that's why the organic compounds has got a very vast and a varied nature. And you will see when you see the nomenclature that one small change of one particular element changing its position from one point to another point will change the complete name of that particular substance. So that's why it is going to be very vast as well as a complicated thing, but at the same time it is very interesting to understand this thing. So let's see now about the unique nature of carbon atom. Now why is that so that we are only having the organic compounds which are having the carbon as the base? Now that is because carbon has got some unique properties. So the unique properties of the carbon make it the ideal or make it the only particular kind of a substance which can form into organic compounds. So first is the tetravalency. So first thing is that the carbon has got tetravalency. Tetra means 4. So tetravalency means it has got 4 valency. The valency of carbon is 4. Carbon has 4 valence electrons. So carbon forms 4 covalent bonds by mutually sharing its 4 electrons with other atoms. Carbon is hence tetravalent or exhibits tetravalency. Atomic number of carbon is 6 electronic configuration is 2, 4. So accordingly we see that 4 electrons, so you can see the electron configuration is 2, 6, 2, 4. That's why the 4 electrons over here are going to be shared. It is not going to accept 4 electrons because it's a non-material. So it is going to share 4 of its electrons with different elements, and this sharing of electrons will form different kinds of substances. The second condition over here is the catenation. Now what is catenation? Catenation is the process by which the carbon, carbon has a tendency to form into long chains of its own atoms. So tendency of an element to form long chains of identical atoms is called as catenation. So you can see that carbon will be forming a compound like this. It will be one C over here combined with another C over here, another C over here, another C over here, maybe a C over here and a C over here. With anything, it is just going to go on. So the valency which is there, it is going to be sharing with itself and having to form a chain which can be present over here. So this chain formation of the chain, the tendency, the formation of such kind of a chain is called as catenation. So catenation is thus the property of elements by virtue of which atoms of the element can link to each other in the form of chains of identical atoms. For example, a long chain or a ring structure. So it could be a long chain like this, or it could be also a ring like this, that one C, another C over here, one other C over here, another C over here, another C here, another C here, and C here and C here. So this way there will be a ring, okay? That could be a ring over here, or it could be a long chain over here like this. So it is just going to be a long chain like this. So if this is a method by which the catenation is working. So catenation is maximum in carbon, since the value of C-C bond energy is maximum. So there are certain substances which have got the property of catenation, but the carbon to carbon catenation is the maximum because the bond strength is very high. So catenation maximum in carbon, since the value of C-C, that is the single bond C energy, is maximum. Thus carbon undergoes self-linking, forming single, straight, branched or closed chain. So it is straight. So this was the one which was a straight one. This is the straight kind of a chain. Or it could be a branched chain like this. So it could be a branching over here. This will be a branching. Or it could be a ring like this. So a ring like this. So accordingly, there will be either a single chain like this, or a branch chain like this, or a ring like this. So this is a closed chain, okay, a closed chain. This is closed chain or a ring. This is a branched chain, and this is just a straight chain. So these are the three ways normally the carbon is going to form into catenations. Apart from this, catenation and tetravalency both together also result in the formation of three kinds of bond between the carbon. It could be, so the third will be three types of bonds, that is C single bond C, C double bond C, and C triple bond C. So the carbon, and between two carbon atoms there is a possibility of sharing just one electron with each other, or two electrons with each other, or three electrons with each other. So in this way it can either form a single bond, a double bond, or a triple bond. So that's why you can see the types of bond which will be formed will be single bond, double bond, or triple bond. So this is the third characteristics of the carbon which helps it to form into so many different kinds of organic compounds. The fourth point is forms isomers, organic compounds, same molecular formula but different structural formula. So that is the one which is over here, which is forms isomers. Now what are isomers? Isomers are those structures, those compounds which has the same molecular formula but they have got different structural formula. Now what do you mean by molecular formula and structural formula? Like for example, if I tell you that I have C4H6. Now the C4H6 when I'm having, it could be, so the molecular formula is C4H6. Okay, that is the same. So the molecular formula is going to be changed. But here, it may happen that this C4 could be like this, that this C are like this. Or it may happen that the C are like this. Okay, and the H are over here. So that is the C4H10 we will take it. So 1 H, 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 year 1, year 1, year 1, and year 1. So it is C4 and H are 10. Here also we can see over here, if you take the valencies over here, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you can see over here, this structure formed over here by 4 carbon atoms and 10 hydrogen atoms, and this is also the same kind of structure where there are 4 carbon atoms and there are 10 hydrogen atoms. You can see in each and every case the carbon is sufficiently giving its own electrons and sharing one with hydrogen or carbon itself. So you can see the tetravalency of the carbon is complete in all the all the cases. So this carbon has got 4 electrons, 1, 2, 3, 4. That's why it is combining with 4. Here also with 4, here also with 4, here also with 4, here also it is 4, here it is 4, here it is 4, and this one also is 4. So accordingly you can see that this one and this one both have got the same molecular formula C4H10. The C4H10 is common for both of them, but here it is such that the chain is formed as a long chain, whereas here it is a branch chain. Okay, so because the chains are different, they are completely different substances. Okay, and since they are different substances, we call them as isomers. So isomers are compounds having the same molecular formula. Molecular formula C4H10 वो सबका same है, पर the structural formula is different. The way the carbon are going to combine with each other, that is different, and that's why we say that the structural formula is different but the molecular formula is the same, and that is what we call it as isomers. So justification for separate branch of organic chemistry due to unique nature of C atom, which includes tetravalency, catenation, and leading to formation of isomers. So you can see that because of these reasons, okay, these reasons, it is justified that you have a complete branch of chemistry. Okay, here the main thing is that organic chemistry is not a chapter, maybe it's just a chapter for you, but in fact it is a complete branch of chemistry. People are able to do even PhD in organic chemistry, so that's why it's a complete branch by itself. So it is just because of these reasons that it is ideal that you are forming different kinds of organic compounds. So that's why we are given over here the justification for separate branch of organic chemistry due to unique nature of carbon, which includes tetravalency, catenation, and leading to formation isomers. Millions of organic compounds are known or synthesized. Almost 90% of all known compounds are organic. That's the main issue. Then 90% of the known thing is kya bola? Okay, plastic. So yes, it is organic. We are having some kind of the clothing, that is polyester, nylon, they are organic. So you can see food में कुछ लिया तो sugar, salt, they are or sugar, then glucose, yeah, or different kinds of sugar, yeah, starch, yeah, proteins, they are all organic compounds. The acids, what is citric acid and all, which is formed in the different kinds of plants, the fruits and all, again organic. So you can see that the 90% of the known compounds what we are using on day-to-day basis are organic in nature. So that's the main part of it, that organic chemistry becomes a very important branch. Now let's differentiate between organic and inorganic compounds. So first is composition. Composition contains nature of compounds, that is in case of the composition contains में आएगा organic compounds few elements, there are very few elements which normally come in contact with the organic compounds, or very few elements are going to tie up, or you can have a reaction forming an organic compound. So they are the carbon, hydrogen, oxygen, nitrogen, then sulfur, phosphorus, chlorine, bromine. There is some also sodium in some cases. So these are the few of the elements which are there. Whereas the inorganic compounds has got all the different elements. So all the different elements in the periodic table, they are going to form the inorganic elements, compounds. Whereas the nature of the compound, now organic are always covalent. Organic can never be electrovalent. Organic will always be covalent compound because it is the catenation वगैरह ये जो भी property है carbon का property है, carbon is definitely going to form only covalency, it cannot form into electrovalency. So that's why it's a covalent compound, whereas inorganic can be electrovalent also. The melting point, if you see the melting point of organic and inorganic, comparing it, of course we know that covalent bond has got a low melting point and boiling point. Hence, the organic compounds will have a low melting point, while inorganic compound will have a high melting point. Next is solubility in water. So we know organic compounds will not be soluble in water, it will be soluble in organic solvents. So that's why solubility in water is insoluble in water, but the inorganic will be soluble in water. Inorganic solvents will be soluble in organic compounds, whereas insoluble in inorganic compounds. Conduction of electricity, non-conductor, because it is a covalency, so no free electrons, that's why no non-conductor of electricity, whereas inorganic compounds are good conductor of electricity. Combustibility and volatility, combustible and volatile, both of they are combustible, that's why they are good fuel. Petrol, diesel, kerosene, all these are very good fuel. Even the wax is a good fuel, so overall it is a good combustibility and volatility. Whereas inorganic compounds, because they are formed by electrovalent compounds, that's why they will be non-combustible, non-volatile. Finally, catenation isomerism exhibited in the organic compounds, not exhibited in the inorganic compounds. Now, the next thing is the classification of organic compounds. In classification wise, the organic compounds can be classified as, so let's see the classification first. The organic compounds, so you can see the organic compounds, they can be classified mainly into two categories. Okay, they will be mainly divided into two categories. The first is the aliphatic and another one is cyclic. So aliphatic is long chains. Okay, long chain or branched, that is aliphatic. So when it is in a form of a open chain, so it is open chain, then it is aliphatic, whereas here it will be closed chain. So when it is a closed chain, or we can say a ring, it is cyclic. So cyclic will be the one which is open chain, closed chain, and the aliphatic will be open chain. Now, in case of the aliphatic, they are the one which are, they are hydrocarbons. So they are hydrocarbons, and these hydrocarbons are in the form of alkanes. We'll learn in detail about these, so not to worry. Alkanes, alkenes, and alkynes. Alkenes, alkynes. For example, this will be C2H6, there will be C2H4 and C2H2. This will be the alkane, alkene, alkynes. Whereas the cyclic, they are the one which will be as homocyclic and heterocyclic. So that is homocyclic, or it is heterocyclic. We do not have cyclic part in our syllabus, that's why we are not going to see this. But the examples of these one, this will be benzene. So benzene is a benzene ring which is aromatic in nature. So benzene is one example over here, and pyridine is over here. So pyridine is in case of heterocyclic, and homocyclic will be benzene. So it also called as this is aromatic, and this is yeah, both are aromatic compounds only. So that is aromatic compound benzene and pyridine are the examples over here for the closed chains. So this is the first part of the thing, that is aliphatic, which is long chain, which is open chains, and cyclic are closed chains. What we are going to study in this particular chapter will be this part. So this is the part what we are going to study. We are going to study in our 10th standard this complete part with certain more things over here, and also the main thing will be the nomenclature of the hydrocarbons. So not hydrocarbons, organic compounds. So that was about the first part. Now we move on to the homologous series, but I think it will do it in the next video.